All right. Okay. So first off, I want to talk about Zybooks because a lot of people have questions about what to do with Zybooks labs. My recommendation is you redo your labs if you have the time. You redo the labs and you time yourself to around half an hour per lab at max. So I'm gonna write it down. So my recommendations. Obviously, complete challenge problems. And then redo your labs. Right? For modules 1 through 7, I say about 15-20 minutes per lab. And then modules, let's say like 8 through 12. No, let's say 12, 12 too recent. Like 8 through 11, I would say like 30 to 60 minutes. I've timed myself doing all the labs already. Um, on average, is about half of these recommendations. So I don't think this is too unrealistic, but um, definitely would try to be somewhat fast for these labs if you do try to read them. My emphasis would definitely be the stuff from exam 1 because you have more recent experience doing file input output and NumPy and Matplotlib, which aren't that heavily tested on the exam in the first place. All right. All right. So let's start with the short answer problems. Okay. So I've typed out all these problems. They're in the same order as they appear in this PDF. So feel free to follow along as you wish. All right. So short answers. All right. So the first question is, and let me zoom in on this a bit. Okay. The first question is to list 5 good coding practices that I haven't mentioned in this course. This does vary from professor to professor and PT to PT of what they say and what they recommend. The number one thing you always hear is comment your code. Please comment. If you don't comment your code, um, more than likely you may not know what you're doing. Or the other bad thing is you can lose your points on the FRQ. And the other bad thing is if the PT misreads, the comments more for us and less for you. When we're grading, right, comments do help us understand your code a bit better. And maybe we can give you a few extra points if we correctly read your code. Right. Another one would be to use meaningful variable names. You should name your stuff like excuse me. You should name your stuff like AAA, BB, C, just very vague, unclear um, names. The variable should make much sense of what the variable is for, what it stores, and potentially what data type it is. And I mentioned data type because some people write list or number or string, whatever. That's always neat. All right. The third thing I would say is don't reinvent the wheel. Python has a lot of built-in functions. For a list, you have max, min, sum, and length. You have different types of loops, for and while. You have all these data types with all your functions as well. Try to keep your code. You can shorten your code just by using what Python gives you. You don't have to redo everything from scratch. It saves you time and saves us some reading because if you do end up implementing something incorrectly, that potentially can be points off. That means that will lead to my fourth point is keep it simple. We're looking for, well, as a PT, I'm looking for code matches rubric. And the rubric generally looks for, did you do what the prompt said for you to do? It doesn't matter how fancy you do your code. If it works, it works. If you have everything we ask for, you're going to get full credit. And that's basically it. For the fifth thing, Fifth thing is plan out your code. Most of the time, you're going to have good code if you plan out correctly, right? Obviously, if your plan goes wrong, then you might have some other issues. But more often than not, if you have a good plan, you can use that plan to turn to comments. And from those comments, you can develop your code and its structure. And, you've heard the lectures about top-down, bottom-up design, all which will help you set out your code in a neat hierarchy. All right. Moving on to number 2. All right. Identify the keys and values and write the command to add the key orange. Oh, I probably forgot to grab a PDF. There we go. Okay. So I have a dictionary right here, right? And remember that all your keys, right, are everything left of the colon. And here's my colon, right? So this is a key. This is a key. This is a key. My values will be everything to the right of the colon. So this is a value. This is a value. And this is a value. Make sure I'm still recording. Cool. The command to add orange for value of 1. So you're just gonna write out your different color, right? So you're gonna use your dictionary and index, and to add, you just put in the new key and then assign it a value, just like that. We can print out the keys and values, and we can double check my answers. Give this a run, and there you go. You can see that the keys I highlighted earlier are in this list, the values are in this list, and you can see that my key value pair is on the dictionary. Let me start this kernel. All right. So the first question is explain how dictionaries are different from lists and how lists are different from tuples. All right. So here's one of the differences. So the primary difference is how the values are stored. In the list, your values have a certain order. Well, I mean, you have a certain order, right? And your key or index in this case is a predetermined value of where they are in the list. The first to the left is 0, the first to the right is like -1. So in the list, the values are stored in a particular order, and where they are in the list relative to one another determines their index, right? In a dictionary, it's a little different. There's somewhat of an order, but the main difference is every value is directly associated with a key that you define. It's not like a list where where Python will assign a number, from 0 to like -1. You have to define the key yourself. But in a dictionary, all the values are associated with a unique predetermined by the programmer. Visually, the other way you can differentiate between the two is that the list stores values in the square brackets, while the dictionary stores values in the curly brackets. Right? Between a list and a tuple, the most important thing to remember is that a tuple is immutable. So the tuple is immutable, which means you can't change its values. While the list is in fact mutable, so you can change the list what you want, you can add stuff, delete stuff, so on and so forth. And again, visually, the tuple stores items in the parentheses, while the list stores in square brackets. Right. That is it for question 3. All right. Identify and explain 3 ways strings are similar to a list. I'm going to write code for this. But the first part is that similarity number 1, if I can spell similarity. Yeah. You can use indexing and slicing on them with the same format. So let's say I have a list on names, right? I'll do myself, Richie, why not? Right. And then I'll just have just my name, right? If I want to index, the first item in either list or string, I can just use, bracket 0, not 1. If I wanted to slice a certain portion, I can also do the same. I will do some info. Does not look how you spell some info, whatever. So you can do names like this, and then I can do name like that. And you can see the slicing works perfectly fine. Similarity number 2 is that you can loop through them with a for loop. If I want to print everything in a list 1 by 1, I can use a for loop. If I wanted to print every character in a string, I can also do them 1 by 1. So I can do for I in range. Nope, not in range. In names, print I. And similarly, for I in name, print I. Right, and there you go. Slight difference. Obviously, it's a list, it's also string, so you could consider a string a list of characters. It's not entirely correct, but for the sake of 1 or 2, it's basically how it goes, somewhat. Or I guess more accurately, a tuple of characters, right? Similarity number 3. Yeah. You can use length. You can use length and see how long a list in a string is. Length means length. Hey. There you go. This is obviously nothing very fancy, right? It's not, oh, we're basically the same thing, but it's just basic things. You can slice, you can index them, you can loop through them, you can use certain functions like length and sort and whatnot. Okay. So number 5 is to list all the data types we have seen in this course and provide an example of each. Identify which ones are immutable and which ones are mutable. I'm pretty sure the only mutable data type you know of are dictionaries and lists. Everything else, okay, and set. All your primitive data types are immutable, so you can't directly change the integer or a float or a boolean or a string. List sets and dictionaries, obviously they're mutable. You can change them, add stuff to them, take away stuff, directly change the value, etc. Even tuples, they are immutable, they cannot be changed. So let's write them all down. I'll start with the primitive data types, and these are all immutable. So we can do a number, we can do a float, we can do I'm missing a boolean and a string, right? Should probably list them out in the comments somewhere. Okay, this is an int. This is a float. Boolean string. And I have immutable collections, and I just call them collections because they're like a collection of stuff. You have your list, so ages 1, 2, 3. You have your dictionaries. And you have your sets. Sets. And your only immutable collection is the tuple. And there you go. That is question 5. Right. Question 6 is difference between top down and bottom up, and name one advantage and one disadvantage of both. Okay. Scroll down, take some space. Okay. When you have top down, you start with a very big task and you break it down into smaller, more manageable subtasks until you end up with these leaves that can be represented with a very small section of code. With these big tasks, you'll delegate them down to these smaller subtasks. And from these, you'll delegate them to even smaller subtasks. And this process goes until each task becomes a leaf. So it can be directly represented with a small piece of code. Right. So your advantage, right? It helps, it breaks down what seems to be a very big task into much more manageable pieces. Manageable pieces, right? It's like a lot of how y'all will be planning your code so far. You take the big prompt and you break it down to smaller things. We break down to even smaller things, like the weather data, right? You gotta, you know, you probably try to break down how to read a file, then how to process a file, and then how to write into the file. Your disadvantage, though, is that your code becomes very specialized. This means it's low reusability. When you break down these tasks, right, you're making these subtasks based on the task above it. That means your tasks are very specific to what you want to do. Eventually, you break it down very far. You might have tasks that are extremely specialized for one very specific thing that can't be reused in other pieces of code that you write. This isn't necessarily a bad thing, but it just means your code will be very hard to transfer over to any other labs or projects or whatever you're doing, right? Okay, And let me change colors, it's a little easier to read. With bottom-up design, you start with tasks you really want to do, right? So you start with small tasks. You start these very small tasks, and then you slowly build your way up into these like categories, right? These bigger subtasks. Dot dot dot, and then you slowly go up until you reach, your end goal. Advantage of this, right, is that um, you decide all the parts at the start. You have to pick and choose what you want to do, right? Oh, it's like a thing Dr. Ritchie used for examples like notification, right? You can plan out all the different little things you want to go, all the places, all the restaurants, etc. And then you can categorize them slowly one by one. And then ultimately it leads up to your main goal of enjoying your vacation. That being said, though, the disadvantage is you can get lost. What I mean by this is that you stray off the original plan, the original idea or prompts, so to say. Let's say I said I want to go fishing, I want to go swimming, I want to go lay in the sun, and all that good stuff. But my original plan was to go, to the South Pole. Um, those tasks aren't exactly ideal at that place, right? So we are doing bottom up and you have all these tasks. You have to make sure that you're on track and on topic as you go up. Because if you stray too far, you might end up making your lab a lot more difficult than it's needed because you have too many extra features, or you end up forgetting something entirely because it did not come to your brain to do such a thing in the first place. So, with that being said, let's clear this and type it out real quick. Okay. So, like I said, top-down design focuses on breaking down bigger tasks into smaller, more manageable tasks that may be representable with a small chunk of code. This could be a small function or just a handful of lines. Okay. While bottom-up design focuses on creating tasks from the get-go and building up / categorizing them slowly. The advantage of top-down is the ability to break down large chunks of work to more manageable slices, which is preferable in groups, right? You can more easily delegate the assignments of tasks. What's the difference between immutative primitive and tuple immutative? I mean, nothing. It's just that the tuple, we're all immutable, but I'm just categorizing like this just so I can like section out these. There's no particular order. I'm just saying that tuples are immutable and these are also immutable. The difference between them would be the difference between the types themselves. All right, so back to question 6. The advantage of bottom-up design allows you to plan your immediate tasks. Get-go. Right. But the disadvantage of top-down design is that the code may have low reusability due to task specialization. Okay, specialization. Okay. Disadvantage of bottom-down design is that you may stray off track from the original idea of such problem. I believe there'll be more about this when you actually do your module 13. We'll have you'll probably have some slide that does talk about this more in detail, but this is how I remember it from when I took Windows 2. All right, so describe the various components of a hierarchy and how can we use in program design. So a hierarchy has three parts, right? Or I guess hierarchy has, wait, let's say this way. A hierarchy contains various nodes. A node equals a task, right? Topmost node is your root, and this generally is the primary objective. And your nodes without children or child nodes, so nodes that branch below them, are called leaves, sorry. And these leaves are, I don't know how to spell, whatever. These leaves are your tasks that are directly translating to code. How you can use them? You can use them to, you can use them to plan out your code. That's basically it, right? All right. So number 8 is, does it matter if you use the same variable names inside a user-defined function in a main program? Why and why not? No, yes. In most cases, it does. Let me do some examples too, because it's hard for me to talk about this. Okay. So let's say I have this a equals 2, right, and a def high. I can still access it like this. Let me restart this. Right. Same variable. Oh, same. Okay, never mind. It does matter. So let's say I have a equals 2, right? And I have a def high, and I do a equals 3. So I'm print a in here. So this inside function. And then this will be outside function. Good. So right here, right, the reason this is scope. Your a right here is a global variable, right? So anything out here can read it. So this whole thing can read a, right? But the second you have this a right here, this is your local variable, right? And within a function, right, it prefers, it prefers local over global. In a lot of cases, if you try assigning a global a value to a global, it gets very, very mad at you. So within this high, right, it sees the a that points at 3. Out here, this a only sees the one that points at 2. Other words, you can think this way. I have my a here that points at a 2, and this is my main program. And then I have my height function, right? And in here, I have an a that points to 3. So this a refers to this one. When we're in the main program, this a refers to this one. And that's why you have these different values. If you set a list in a tuple, then change the index in the list after defining the list in a tuple, the list in a tuple will change. Yes and no. There are certain things you can change about the list, but there are things you can't do to the list. It's kind of awkward, but um, as long as you don't, I think as long as you don't recreate the whole object, you'll be fine. But that means you have to remember what functions and what you have to find which ones actually affect the list itself and which ones return a copy. And that is rather dangerous to do. But I think it's mentioned in a later question anyways. So we'll get to that when we come to that. All right. I'll put a comment here. The difference is due to global and local scope. All right, so does it matter where in a code we write our function definitions? And the answer is yes. If I put x equals y, if I say def y and return 2, I do print x, be an error. Remember that Python is a sequential language. It goes for each line one by one in order. So it's in first look at this line and say, oh, in our main program, we want to point x into this thing we call y. But in here, where's y? So that is going to be an error, as you can see right here. Name y is not defined. Now, if I switched it around, we had a little different. Let's start. This time, when I do it, we actually do get return. Because now in our main, we have this function y, and it returns 2. Then, so it's this part, right? Then it does this line. So you have a value x that points to the value returned from y, which is 2. So you print x, this 2 goes out to the console right here. Therefore, our answer is yes. Yes, it does matter. You must define the function first. Okay. So can functions access main memory? How do we pass information into a function, and can functions return multiple values? Okay, functions can access main memory. It can read main memory. So if I did a equals 2, right? My example from before. I can read main memory. Right? I can read the main memory. This here, right? This whole thing is global. Oh, sorry. This whole thing, right? This is main. This is my main memory, right? I have an a that points to a 2, and I have a function y. You can see this function. I am able to read number 2. However, that is just reading, right? I can't actually change it. So if I try to do this, I run it, right? um, it can't access. So you'll see something like this. This plus equals 4, right? Um, it's very interesting because it actually does this. It'll store in like consider y as its own memory, right? Let me draw this. So consider y as its own memory. So when you execute this line, it's going to say, oh, it is a temporary memory, right? It's going to store a plus 4. But in this, in this function itself, it's asking, where is a, right? The a is out here in main, but that a equals 2 is outside, right? It, the function does not see it within itself. So in this case, it's going to throw an error that the local value a does not have a value. Um, this is why you need to pass in a parameter in order to do stuff with it. And I'll answer part 2, which is you pass in by using a parameter. We'll call this b, right? Two. There you go, right? Now this works. Why? When you, again, consider this as its own memory, right? From main, right? This 2 gets passed in here, right? So the a equals 2, right? This value gets thrown here, where b, the parameter, is waiting. So it's taken the 2. And now you have 2 copies of this value because it's going to give it a copy, right? And now when I execute this line, this 2 becomes a 5. When I execute this line, it's outputted to the console. This is why passing the parameters is so important. And there's the global keyword, but this should be aware at all costs. You probably don't have a good reason for it. I don't usually have a good reason for it. Most of the time, you can ignore global and pass in your parameter. Can functions return multiple values? I want to say yes. It's a little technicality, I guess. Um, it technically it returns one value, but that one value can store multiple values. That's why I think this question is a little weird. But let's consider this define a, right? And I'll just return 1, 2, 3, 4, and my name, right? I print a. I get a tuple with all my values. So functions can read main memory, but cannot. Wait, this is code still. Functions can read main memory, but cannot directly change it. You can use parameters to pass information into a function. Functions can return multiple values. They're just stored in a singular tuple. There you go. Right. 11 is what type of coding error do you hate the most and why? I have all the coding errors, right? There were 3 errors, or 3 types. So there are 3 types of errors. You have syntax, runtime, and logic. Syntax errors are errors where you completely misspelled something. Basically, Python will read your code and think something's immediately wrong. Maybe missing a colon, you indent it incorrectly. It's stuff it can see as incorrect just by looking at your code. Runtime errors are errors that happen when you run your code. It's like when you divide by 0, Python might not be able to predict it right away, but when it runs and it counters that error, it's going to throw an error at you. And logic error is just an error in your logic. It's not necessarily going to throw out an error at you, like for output, but it's still an error. That being said, errors, sorry, are the ones I hate the most because they're the hardest to debug. Correct answer is no. Okay. Um, functions can not return. Thank you, Dr. Ritchie, for clarification. But it can return a tuple that contains multiple values itself. All right, there you go. All right. When you're trying to fix your code, what are some alternates to using debugger? So there's two ways to debug. Oh, outside using debugger. One is use your eyes. You can look at your code, and that's what a lot of PTs will do. They'll just look at your code and see if anything looks particularly strange or outright incorrect, right? When you're familiar enough with the code, you'll start to recognize when code doesn't look about right, and that will be where we start testing. When we actually do that testing, two is to use a lot of print statements. If something goes wrong, it's because one of your values is incorrect. So obviously, if you want to check a value without using a debugger, you gotta print out to the console. If your loop is going haywire, you can put a print statement inside your loop and check at what point does the loop start doing crazy stuff. It's also helpful if you have a lot of conditionals, which is a lot of branching. You can, excuse me, you can put in some print statements, see if you're getting the expected output, and if not, you have identified your error. Okay. When is it best to use my file equals open and my file.close versus using with open? I'm not too sure if there's a definitive answer to this. On a personal standpoint, I prefer using open if I have to reuse the file over and over and over again. I rather just open first and then close later. Also, but with using with open, it's the safest. It might not look so pretty if you put everything inside the with statement. It might look kind of off. But the nice thing about with open is that if something happens to your code unexpectedly, like an error, Python will still close the file for you. Obviously, if your code executes perfectly fine, then Python, of course, it will close the file for you. So, personally, I will use open if I have to reuse the file over again at different spots. However, I generally prefer to use with because I can open multiple files at the same time, and Python will guarantee the opened files will close correctly even if the program faces an unexpected error. That's it. All right, so for opening files, what's the difference between R, W, or plus of A? Okay. R is for read-only mode. W is for write-only mode. R plus is for reading and writing mode. And A is for appending mode, or append mode. If you just need to read your file, right, safest bet is to use just R. You want to restrict permissions as much as you can to avoid anything unexpected happening to your file. You know, it's like if you let someone borrow something from you, right? You're not going to give them the keys to your apartment and get it yourself. You know, just give them the item and restrictions to, you know, just use this for, you know, legal reasons. No, you don't want to permanently be in write-only mode because every time you open the file in write mode, you know, R plus or W, it actually clears out your entire file. So if you would like to keep your file intact, would use append or read. All right. Right. So what are the differences between myFile.read, myFile.readLine, myFile.readLines, and list my file? Okay. Read lines and list are essentially the same thing. Read gives you the entire file as one big string, and read line only reads one line and moves the cursor down one. So read will return a string with all the lines attached to each other, right? And then read line will return the next line and moves the cursor down one if there is a remaining line to read. Read lines and list my file. Essentially do the same thing. Returns a list of all the lines. Each line is its own string. And there you go. That's question 15. Question Question 16. What commands are used to remove the leading and trailing white space in a string, and to separate a string to a list of its components with a specified delimiter? Right example using both. Okay. So let's say I have my name that's very weirdly formatted. Okay. If I want to strip it, right? If I want to strip the string, right? I'll use .strip, right? If I want to split on the delimiter, I'll just use .split. And there you go. Let me print this out in its complete raw version. You can see this string has absolutely no white space in front or at the end. Remember, when we say white space, it's not just the space, right? This also includes new line. And then if you maybe in Java, you see character return. I believe /b is one of them as well. And then you haven't used this much yet this year or semester, but /t, your tab new character, also counts as white space. For the sake of this course, you probably only need to remember that it does the space and your new line. Oh, that's a terrible line. There, your space and the new line. And that's it for question 16. I'm sorry, just sneezed. All right, so moving on to the next question. Okay, so write a command to print the value pi to 4 decimal places. Don't forget to import pi for the math module. So first off, we're going to import pi, right? So we do from math import pi. And now we do some abstract magic to format pi to 4 decimal places. And there you go. That's pi to 4 decimal places. All right. Write a command to import a coolfunc function for Nito module in the funpack package and rename it to coolf. Now write a command to import all functions or Nito module. What command can you use to obtain the list of all functions inside the module? Oh, I actually don't know the last question. Let's see other two though. There's gonna be some errors, but we want a cool function for Nito module in the funpack package. So we can do from funpack.NitoMod. Import coolfunc. And then I write the command. Okay. Then I can import everything by saying from funpack.NitoMod, import all. And let me see how you do all of them, because that is something I've never considered before. I don't think it's help. I think it's there. Let me try there. Right, cool, it is there. Okay, cool. Um, all right, and there you go. That is question 18. Where is my chat? There it is. Yeah, you preferably don't want to use um the star, right? It's oh, that's cool. F, sorry, thank you. Yeah, you usually don't want to import all like this. It's very awkward. Um, especially with very big packages like matplotlib, NumPy, math, etc. It's even Turtle. It's easy to have overlapping functions, or you name your variable equal to a function. It's very awkward. Just import what you need, or just use the import, import funpack.NitoMod as something, right? Like with NumPy, we say import NumPy as NP, and you can save yourself with typing with your np.something, but still clear that you're using specifically a NumPy function and not something from a random another module or your own function or accidentally your own variable. Thank you, Dr. Rishi. All right. So what are the differences between np.arange, np.array, and np.linspace? How many rows and columns would matrix 15 would a matrix np.arange 15.reshape 5.3 have? Okay. Arange. It's basically NumPy's version of range. Right. Array is NumPy's special version of a list. Specifically, it's like a matrix. But if you're not in Math 304 and it's linear algebra, you won't have to worry about it in a while, or at least anything that requires a matrix, right? And then linspace, this gives you all numbers between two numbers, depending on your input. And I'll talk about linspace more in detail. It's hard to write in words. Okay, but the first two are easy enough. Oh, sorry. And this last question, you'll have 5 rows, 3 columns. Right? So let's play around with this a bit. Let me start this. All right, input NumPy. And first I'm going to print np.arange to 0 to 10. We'll also do print np.array 1, 2, 3, comma 4, 5, 6. we'll print np.linspace, do 0, 10, and 30, right? And we will print np.arange 15.reshape 5, 3. Queued comments must be, oh, right. Encapsulate that. There you go. So, right, you can see this arange, right? This is basically the same thing if I did list range, so you call it 10, right? So it's basically the NumPy's version of range. It's really neat when you're plotting, especially. You can very quickly make your x-axis, your y-axis labels with arange or just a random set of numbers. You can see my array here. I have my first array right here, my second array right here, and the big array was encapsulated by this and this. Linspace, you can see there are 1, 2, 3, 4, 5, 6 by 5. These are 30 numbers. Okay. So the number of numbers in this list is equal to this number. And this tells you how many numbers you want. And this is your start and end, right? So this is my start. This is my end. And this 30 is the length of my numbers, right? And then for that reshape, like I said, you have 1, 2, 3, 4, 5 rows and 1, 2, 3 columns. And that is it for question 19. All right. So what are differences between plot, bar, histogram, scatter? Okay. Differences between those two, or those four, is the type of plot. Your standard line, and you have bar graph, histogram, and scatter plot. You want to set the color, right? Inside of the plotting function. Declare the line style to change both the color. Oh, sorry. Declare color. Set the color. Also, you can declare the let's say it's line style. I'll just say line style because I don't remember the actual attribute. Line style to change the marker shape. The axis labels can be changed with. There's like 6 ways to write this. Let me recheck this real quick. Change axis labels. Property. It's probably set. Right. I'll just use a standard one. We'll do set x label and set y label. You can set the title with title and set the legend with legend. There you go. That's question 20. The important part of this question is that you recognize like the names of these functions. They're pretty straightforward, right? Like dot legend should change the legend. Dot histogram, dot hist will be the histogram. If you see something that changes the color, it probably changes the color. So it's somewhat straightforward, but do just try to remember what we generally do, right? And why is it useful to include Docstrings for any functions? This allows you to better document the function and lets users use the help command. And I'll do a quick example. Do def high. My docstring will be size high. We're gonna do a big funny and do print by, and I do print help high, and there you go. All right. So any questions so far about the short answer section of these reference problems, practice problems? Yeah, very different. So a range, right? It's similar to range where you have your start and your step, right? This is not your step. This is how many numbers you have in the list. So essentially, it's gonna split. You know, it's gonna do like um, it's gonna put in as many numbers equidistant from one another. So lens space is like give me 30 numbers between 0 and 10 inclusive. A range will say um, give me integers between 0 and 10, inclusive 0, exclusive 10. Right, for now, we shall be on break for 5 minutes. When we come back, um, we will do the auto-graded part. The auto-graded part is true, false. Will this have an error or not? And if it has an error, explain why. It's questions 22 through 36. Question 36 in particular is not a true false. It's more of draw the graph based on what you see here. Right? The time is 3:09. We'll reconvene at 3:14. If you have any questions, feel free to ask. Um, I'm gonna get some water real quick, but I'll be right back. All right, it's 3:14. Let's play this program run. It's not a fun game. I get 2 points on the exam when I ask about it, so it's good. All right. So the way I'm going over the section is I'm not gonna hit play. Let's start. Okay, sorry, give me 1 second. All right, I'm back. Sorry about that. So what I'm gonna do is I am going to um, talk my way through of how I read a code, and then pray I'm correct because it'd be a bit embarrassing if I was wrong. And then when I press play, and then we'll see if I was right or not. Okay, so let's start the first question. We have these two tuples. So you have a tuple here, and a tuple here, and then we're gonna multiply them together, and you do dot product. If you remember anything from, I want to say, actually, I don't know what would this be calc one? I'm not sure. But if you do dot product, right, you'll do this should become 1 times 2, 2 times 3, 3 times 4. Right? Just be 2, 6, and 12. Except in Python, doing this is not allowed. You can't directly multiply tuples. So this whole thing should be incorrect because of the multiplication here. And if I press play, yep, you cannot multiply a tuple. So the first question is, or the first problem does not work. Excuse me, sorry. All right, question 23. You have a string. Looks good to me. We have this list. Looks good to me. We have this tuple. Looks good to me. We have this thing. This changes to 7. Looks good to me. You want to fix the ones with errors? Sure. Let's go back to the first one. Okay. So our dot product, we get a little fancy. We'll do def.p dot product. V1, V2. Okay, I want to be very strict. We'll say if length V1 not equal length V2, then we return nothing else. Final value, nope. Our values equals this, right? And then for I in range V1, final values dot append V1I minus V2I. Return final values. And do dot products vector 1, vector 2. Oh, whoops. My brain cooked a little too fast. There you go. So this will fix the mistake. You know what I should do? I should make a separate code for the correct solution. Dot product. Dot product gives you a scalar. Oh, I'm just dumb. Okay. Let me I don't remember dot products. That's what you get when you haven't done physics in a semester, I guess. Question 22 fixed. Final sum. and I do this. And bingo, 20. And that'll be 2 plus 6 plus 12. There you go. Read on this, show the error. Cool. 23. I guess let's go back to, oh, sorry, video, sorry. So, like I said, right, my pen's upside down. This is fine, this is fine, this is fine too, this is fine too. This becomes, this is index 3, right? 0, 1, 2, 3. This becomes a 7. I print my tuple. I bet it's going to print out howdy 2027. That's exactly what's outputted. Well, with the single quotes, but that's not a big detail. So why was the unit of my list has a 0 here? Oops, sorry. The unit of my list has a 0 here. Why is here 7 here? Like, why is this even legal? So if we look at how this memory is done, right? So you have my string is howdy. You have my list that points to a list. Exact details are not needed to be known. And my tuple, right? It will take in the string, right? But this place in particular also points to this list. So when this line executes, right? This becomes a 7. But you can see that oh, I should move that a bit. That's how we want it. There you go. You can see that this 7's changed, not just, well, the list does change, right? But this list is also the same exact list for a tuple. That's why this 7 right here gets changed. Now, like I said, right, there's some things you can't do to the list. This is anything that will cause the list to be completely changed. If I did my list.sort still works because sort just changes it in place. Now, if I try something like this, okay. Now you can see that the list doesn't change at all. This is very interesting. Why? So when we have the my list here earlier, right? And I set it points to this 2020, right? And this being the tuple, right, also points to this list. Well, this line though, what I basically said was I want my variable. Sorry, let me erase that. I want this variable to now point to something else. Just this 1, 2, 3. You can see that earlier these two were pointing to the same list, but they're just pointing to the same thing. So you change that thing, it'll affect both of them. But you can still, well, not a tuple, but you can still reassign to something else and have this completely intact. This is also why lists are particularly dangerous to use as parameters. I mean, it's inevitable sometimes, but you realize that when you pass in a list into a function as a parameter, you can still change the list. That's why .copy exists, where you can string slice everything. I'll do a quick example of that to show you what I mean. Actually, let me do something else here. We'll do minus 0 equals 2. Yeah, that'll also work. So what the thing is, okay. Now, this doesn't work because I'm actually trying to change the tuple itself. I'm trying to change the thing it's pointing to. Um, so earlier, right, I set my tuple. So I asked the howdy, right? And it's pointing like this value is to this list, right? As long I change just this list, I'm fine. If I try to change what this arrow points to, then we're not fine. If I try to change this, I want you to point to its empty list, right? This is a no-no. That's the error cut right here. If I change this to a 1-0 like earlier, completely fine. So again, lists kind of weird, but do be careful with them. Just one more thing I want to try real quick for it's my list plus equals 1. Try this real quick. That works when this doesn't work, right? Oh, that works too. Okay. So like I said, as long as you only change the list, you're good to go. I think the original command here is my list 3 equals 7. This whole question was basically, do you understand list mutability? All right, so question 24. So I define the function first, and then I call it. So far we're good. So first I call this function with x being 2. So if x is 2, right? Then I return x plus 1 is 3, comma x plus 3 is 5. Now I want the 0th index of the return, so I should get just the 3 out to the console. And there you go. Easy peasy lemon squeezy, hopefully. Even my pen color matches. All right. So question 25, we have this function, looks good. This is a docstring, so this won't be an error, also looks good. Print statement's fine, help will also be fine. And there you go. The docstring message for help. Oh, not for help, for my fun. All right. You can see my IDEs or flagging as an error, but let's go through this, right? So I have a function, right? And this right here is no. Why? When you, like, let's say we ignore this, right? If we ignore this equals 5, is ABC, right? If I call this my function, right? It will assign 1 to A, B to 2, C to 5. 3, sorry. Now, the thing with default arguments, right, is that if you're missing something, it will default to that. But here's the problem with how we wrote it. Let's say my function, which is my function 1, 3. My intention is A goes to 1, B defaults to 5, C goes to 3. However, this is not how Python does stuff. How Python does things is that it goes in order. So A is the first parameter, right? A is first parameter, so it's 1. B is next parameter in line, so it's 3. C is missing. There's no C here. So this function will be incorrect, right? You can also say that it's vague. Because of this, right? When you put the default value here, did you want to assign this value to C? Or did you want it to assign to B, but you assign to B and C is missing value? So because of this logic hole, you need to have the default arguments, an argument or parameter with a default argument must come at the end. So if I run this, and there you go, non-default argument follows default argument. If I want to fix this code, we'll just do like this. We'll do CB equals 5. and that's fine. If I even left out the last number, see, 1 times 2 times 5, and that is 10. We haven't really touched default arguments much, like at all, but it was mentioned in your functions module. I believe it's module 9, I want to say. So do be wary about this, all right? All right, so question 27. All right. This line looks good. If statement looks fine, returns fine, else is fine. Same indentation level, that's good. Return, that's completely fine. Okay, so if add 1, add 27. So we add 1, right? So x plus 1 equals 2, which is less than 10. So this line should execute, and I should get 2 space. And 27 plus 1 equals 28, which is larger than 10. This does not execute. I do Tuple. From there, you press run, and there you go. All right, so this is what I said earlier, right? The order of the functions does matter. If I run this, we're gonna get an error. We're gonna fix this. We just need to swap around which one goes where. So this, we go right here, and I restart this kernel so it doesn't remember to save the value. It works. All right, question 29. Right, so I have this dictionary. Everything looks okay, nothing out of place. If this key is in the dictionary, that's valid. We can do a print statement. They're valid, and that's valid. Okay, so nothing, like these two are in the right order. They're not flip-flopped on accident. They're all indented properly. This in is used correctly because you can check if a key exists in the dictionary or not using in. So, Joe is not indexed, so this will not run. And is indexed, so we should get this. And there you go. We got the output as expected. All right, question 30. Okay, let's look at this. Empty dictionary, completely fine. Wine list, also fine. Valid list function, valid as well. My list one's right here. This is 3, 0, 1, 2, 3, and it's -1, also valid. And for key, my dict prints key. Okay. So I should get length. Length should be 5, right? The max should be 5. The min should be 1. Am I crazy? Should be, this is 2 times 4 minus 5. I hope that is 3. And we get exactly that. You'll have questions, feel free to ask. Not quite sure if Dr. Ritchie is always here to answer, but I will of course be here to answer if I can. All right, question 31. Okay. So we have a string, that's fine. Split, no parameter, which means this have a list. We'll get howdy, welcome to Texas A&M engineering. That's fine. Empty string, looks good to me. So range 3 to length of my list. So this will not go out of bounds. That's fine. New string add. So my new string at this point, we start at 3. So 0, 1, 2, 3. So we should get Texas A&M Engineering. This time with a space at the end though, I said this. Okay, so that line's fine as well. So we print y-list 0, so this thing right here, up to next 5, so 0, 1, 2, 3, 4, 5. So this is just howdy. Okay, and then we add the space, fine. New string up to -2. Am I missing something? Oh, there's an exclamation mark here. Okay, so remove the space and exclamation mark. So this should be Texas A&M Engineering. And then we add the students. So the whole output should say, howdy Texas A&M Engineering students. And we run that. And bam, that is exactly what you get. That one is all good to go. All right, so question 32. All right. This is fine. This is fine, this is fine, this is fine. Okay. Pop seems to assign to anything, right? So we pop remove this one. 2, 4. I believe it's insert for index 2. So we have a 2 like right here. And we sort, so you get 1, 2, 3, 5, 7, 9. And then we should output all of that in a single 1, 3, 4. I keep wait. I confused myself. I even said it correctly. I didn't catch myself. What I meant to say is at index 2 we insert 4. 4. And this becomes 1, 3, 4, 5, 7, 9. And then with this list, we get 1 space, 3 space, 4 space, 5 space, 7, 9 space. And there you go. Yeah, and 1, 3, 4, 5, 7, 9. If I highlight this, you can see that there indeed, the space right here is right here. All right, cool. All right, figuring out to Richie. See, question 33. Okay. I wrote the comment myself, but okay. So we input a number and we can try to cast it in and we'll try to print it out. Otherwise, we will cast it a float and then do it. Okay. So okay. So the assumption here, I have to assume that only numbers are inputted. If I assume this, right, then it works. Because if I enter like 5.0, right, this line will fail, cause me to go into the accept, cast to float, which gives me 5.0, and gives me an output, right? But if I did something like this was like A, right, this would fail and this would fail. And the whole thing would fail as a result. So let's highlight that real quick. So we're gonna do this. So if I put in like 5.0, right, we have to flip. If I run it again with an actual integer, we get the integer. But if I run it with a letter, it breaks. So the thing to note here is that this code only works if the user only inputs numbers. I'm not quite sure how you would fix it. Why does the try block fail? Okay, so if you cast the string 5.0 to int, right? This is impossible. You can turn the actual float into an int, and that's completely fine. That gives you 5. But to cast the entire string to an int, you can't do that. You would have to do 5.0 into a float, which gives you 5.0, like the number, and then to an int, which gives you just this front part, the 5. But here to here, you can't. That's an error. So I'll leave this here as an example of why it doesn't work for any letters. You can fix this by putting another try except. So we can do in quotes fixed. You would have to chain another try except if you're going to try. And we'll say except print x is neither a float or integer. For this, right? If I type in 5, I'm good to go. If I do 5.0, we're also good to go. If I type in like a, well, it's not x, sorry, I mean number. If I mean a, there you go. That is the fixed version of question 33. All right, question 34. We have a NumPy. Okay, so NP A range. Okay, so if 9, this right here gets me 0, 1, 2, 3, 4, 5, 6, 7, 8. Now reshape makes a 3x3 matrix. So if I go in order, I'll get 0, 1, 2, 3, 4, 5, 6, 7, 8. We have all numbers. This is valid. Okay, grid 0 should give me this. Then 2, 2, this is just different colors. This line should grab me this whole row. This line should grab me just this number. And that's what we get. I believe you can also write it like this. Nope. Remember that with NumPy arrays, you can actually do a singular square index and do value, common value. Now, the first one is your row. The second one is your column. So your x and y essentially. Your x and then your, well, I guess this is your y and your x, right? Or x and y, however you want to see it. Annotate, delete. All right. Restart. All right, so let's look at this file. All right, so lens space from 1 to 10. Okay, so if 1 to 10 should be like 1.0, 2.0, 3.0, only 10.0. That'll be 10 numbers, right? Yeah. Y equals x squared minus 1. So we'll square every number and we'll get, so 1 squared is 0. This should be 3, well, 0.0, right? This should be like 8.0, I believe, and it'll be like 99.0. Okay, so I open a file. It opens fine. That means this file does not need to exist. So far code is still good, right? Rename it, so that's also good. Okay, these are right. We're in the correct write mode, so that's valid. So we make a header line, and then for each value in x, we'll print each thing out like this. And then we reopen it again, and then we print the output. It should be all correct. And there you go. You have your output, your headers, and then 1 through 10, that is from your x. And then all these values are from y. Open here, you can see from Z file, I have this. You might notice why this line is so far out, right? So if you count the tabs, right? Um, it's kind of weird. I don't know. So you have like four right here, right? So that takes over. It's actually going to move it over one more. The behavior slash t is not something you have to remember, but it is nice to know that you can have something that um, fills in a whole tab for you. That's slash t. Like let's say one whole tab is 8 spaces, right? If you do like print high slash t by your high, right? With a slash t, we'll do 1, 2, 3, 4, 5, 6, and that's your 8. And then your next tab, your start, and everything else. It's good for spacing, but it's kind of awkward if your tab size is small. Like if it's 4, then it's kind of awkward. It's also why you have center and R just, O just, and all the nice string alignment stuff from F strings, so you can better control that alignment yourself, which you did for part B of small functions, I believe, for that name card. All right, so this is good. All right, so 36 wanted me to draw it out. Okay, so let's assume this box like is the graph, so everything else like outside, right? So length space -2 to 25. So this will give me 25 numbers from -2 to 25. So 25 numbers from -2 to 2 inclusive. I can't spell. Go back to 36. Sure. I'll go back real quick. I mean, this is 36, but I mean, you think 30. Wait, am I missing a question? 35, 34, 33, 30. Am I missing a question? Hit this, that, and that, and this. I probably mistyped something, but anyways, this would be quote unquote 36. Wait, where did I miss number? I don't know. That's 36. This should be where? Yeah. Sorry. I'll stop scrolling. Yeah. So this is 35. I'll recheck and see what question I missed in a bit. But anyways, for 36, right? This one. What I'll do is plot the thing below. Okay. So where's my up here? Okay. So this gives me 25 numbers from -2 to 2 inclusive. Okay. So y1 equals x, y2. So this will be your linear plot, I'm assuming. And then you have your square plot. Okay. So this G is green. So I'll highlight that. So this is green, thick, free. So got kind of thick green line. All right. And then we have the second line. K is black, because B is reserved for blue. This is black, marker O, face, okay. And this is blue. So we're gonna have a line with blue O's. And that's at each point. Okay. Axis, right? So this is going to be your x-axis is from -2 to 2, right? And this first part. And then this part, right? Your y-axis is from -2 to 4. And that's how those 4 values are in order, right? We got our labels, right? So this is going to be x. We'll call this f of x. I would write sideways, but I can't write sideways. So we're gonna do that. Actually, let me scroll down a bit. Um, yeah, actually, yeah, we'll do that. Annotate, select. This was like right under here. There you go. All right. So back to drawing. So f of x is here, right? This is so we said -2, right? Oh, sorry, -2 to 2. So you have the -2, you have the 2. We'll put like 0 right here, right? That's -1 and put 1. And then you have, well, okay, if I want to be more accurate, I will use black. Those default colors for Matplotlib are black. Erase this, erase that. Okay, this is f of x. Okay. So this goes to 4. This is -2. Like right here would be 0. No, right there. So -1, 0. Oh, we can't half like this. 1, 2. 1, 2, I think. 3, 2, 1, 0, -1. Great. 1, 2, 3, 4, 5. Right. -2, -1, 0, 1, 2. And this is your x. Right. Your title is plots for two polynomials. Right. Now I'm plot the graphs first. So with my green line, it's kind of thick. So I'm gonna do green and then change. Actually, thickness. Oh, it does. Okay. So my first line's gonna be linear, right? So we're just gonna do something like this. All right. It's not my best, but I'll try to redraw it. Okay, it got rid of it. This is my linear line, right? And then you're gonna have your sorry, your curved square line, your square plot, right? So we're gonna change this into black, because it wants a black line, right? And we're just gonna do your normal width, and it's gonna dip down here to 0, and then dip back up. Let me redraw it. Wait, it's so hard drawing on tablet. There you go. Okay. But now we need these blue markers, 25 of them, I'm pretty sure. So you have like 1, 2 here, 3, 4, and 5. So 5 is 20 more, right? So we do like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Oh, I guess we need like 3, 4, 5. Okay, about 25 dots, right? So this is, oh, sorry, one last thing. I need to do the legend. So it'll be a box in the center, because it's an upper center. Oh, wait, not that far up. Upper center. And then it's going to be, you have straight. And then you have curved. I might have put this on the wrong side, but it should be close enough. We have a line here with the blue circle. We'll have the, I see your question, but let me finish this real quick. With this. So this is what I think the plot should look like. Okay. So if I take a look at this, all right. If I clear it, and we go back to here and we run this. Yeah, I did have it on the other side. You can see there's 25 dots, right? And then here's your X, here's your Y, sideways like I said, right? -2 to 4, -2 to 2, straight line. So I pretty much got it right. If you didn't have this, Matplotlib will decide for you. So it makes it a little more neat, a little less stingy on the. It makes it like what is it, more inside. The way you define this, right? These are your absolute ends. Go all the way up. There we go. Now let me go through these problems and see which one I missed. I'll say 22, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6. Oh, I didn't label this one. Question 35. Okay, it's not options. All right. So any questions about the autograded section? Okay, I wouldn't consider this to be autograded. Like, it says autograde style. Like 36 isn't autograded for obvious reasons. It would be nice if we had AI to do that for us, but you know, I'd be out of the job in our case. Or realistically, I just put it in here because I didn't know where else to put it. But these are code writing problems. But you can see, right? You don't have to know like exactly how to do something. Yes, you have to recognize, but usually you have to recognize the basic values. Extra question for 36 might be which code snippet plots the following. Yeah. For those of you be watching this and can't see the Zoom chat, Dr. Ritchie said that if she were to make number 36 an actual question, she will describe a plot with certain properties to you. You'll need to find out which code snippet actually will make that graph. The things I would definitely be looking for though is, okay, the most important things you'll usually see are, okay, title is very obvious. I'm sorry. Remember that Python doesn't like doing things, so you tell it to, right? So make sure that, you know, it doesn't ask for a title, don't put a title. But it does ask for a title, put a title, right? Title, how the legend done, right? This is very English, right? You have lower, lower, upper, right? And then you have left, center, right. If you read that the legend is in the lower right, it will have the legend in the lower right. So it's pretty straightforward in that regard, right? Make sure this command is there as well. If you do all of this, but you don't show it, nothing actually shows. What else is there? Make sure you're plotting correctly, right? If it asks for a bar graph, please use the function, you know, bar for bar graph, or histogram, or hist for histogram, or scatter for scatter plot. So the type of graph is also important. If they mention any axis attributes, you'll be looking at this, or this, and or this. Now, obviously, the line shape will be defined by however they define their x and y values. Right? Essentially, if you can read your module 12 weather data, like the data plotting map individual, and you can like read and understand what it does, you'll be good to go. I think. I haven't really seen the exam, so I'm not quite sure. Even if I did, I'm not allowed to talk about it. So that's all I can say about Matplotlib. All right, any other questions about these questions so far? All right. That being said, it's now 4 o'clock. we'll reconvene for a 5. What do I have planned for the next 2 hours? I'm going to be going through, I'm sorry, I'm going to be going through these coding problems in excruciatingly close detail. I'm not just going to sit down and write my plan in code. I will, as I talk about stuff, I'll also talk about the general way you should be doing something, and that will take up some time. There are 1, 2, 3, 4, 5, 6, 7 of these questions. So each of these questions will take me around 17, 16 minutes, 16, 17, 18 minutes, right? So still rather fast paced, but I do want to emphasize certain parts because these prompts are um, except um, except this one that needs change. Where is it? Yeah. This one is edited on the multi-section to be correct. If you read 37, you can see why this is wrong. Output in particular. But yeah, we'll reconvene at 4:05. My plan is to go through these 7 questions in very, very, very close detail and talk not just how the code works with this prompt, but how you can use similar techniques or I guess code snippets for um, either prompts. And again, um, I have the old version, the one on Canvas on the multi-section has the um, correct bad input output. Put break. Reconvene at not 4:05. You're still here. I might change the end time to 5:55. I'll still finish everything, but my fellow coworkers, that sounds oddly professional. PTs, or I guess TAs, Lily and who's she partnered with today? Where's schedule? Schedule. All right. So Lily and Andrew will be doing another meeting today at 6 to 8 p.m. So you're still somehow willing to watch their review. I'll stop a little early so you have time to rest and watch their review. Their review, I'll just show it on the screen. Their review is from their review is right here. It's from 6 to 8 p.m. today. We'll be going over containers, so like list, dictionary, sets, and I'm missing one, tuples. And we'll also be going over files, like file input output, and practice problems. If you need the link to the schedule, let me find it real quick. Put this right here. Discord. The links can be found on our Discord server. It's also in the multi-section announcement that Andrew sent. Um, but it will be texas.ag/exam2 review schedule, and I'll put that in both chats links. That will be that one, and this will be for that one. And then if you need the practice problems or recordings and practice problems so far and whatnot, they will be in our TAO review drive, also linked in both chats. Please take a look. Feel free to take a peek around, see what helps you. There should be materials for exam one as well. Speaking of which, it's 4:05, so let's get the rest of this done. And I'd say I should drink more water for a while. So question 37. That's on it. Okay. So question 37 states that actually I'm going to split screen this. Okay. So question 37 says to assume function is primes available to you in a module called engineering 102, which determines whether or not a number is a prime number. The function is prime takes in as a single parameter, it takes in as a parameter a single integer and returns either true or false. Write a Python program that takes as input from the user to integers. The user gives back input, continue to prompt them to try again until they enter two integers. Then test only the odd number between and sorry. Then test only the odd numbers between including those two numbers to check if they are prime using the isPrime function. Have your program print a list of numbers found. And no prime numbers were found. Have your program print this message stating that. And start your code at following line. And you do not need to write the function, only call it. This is a problem that's been given before, like similar format. You'll be asked to import something and you call a function. Whether or not this type of question is on the exam or not, I don't know. I'm just saying from experience, I've seen this question before. Pretty sure it's when I was a student. It's not the exact function as far as I know, but close enough. So when you see this function, right, it's like this prompt. It's like when you've been asked to assume the following list of data is in your program and write code for it. You do not need to write out the whole function or anything. Just call it and assume everything that is given to you is done correctly. However, for the sake of this practice, I will create the actual function because, well, I can't really test it if I don't have something to go off. So call engineering 102 and not py. All right. And we're going to have def is prime equal x. Determines if x is prime or not. And we'll do it pretty simply. So, let me open this again. Close. Right. So, your basic restrictions of x is also equal to 1, return false, right? If x equals 2, return true. And then for I in range, 2 comma, you can x, that's fine. Return, if x mod I equals 0, return false, return true. And we'll try out some numbers real quick. Oops, sorry. For I in range, let's do like 20. Print I comma is prime I. Double check this real quick, make sure I'm not being stupid. 2 is prime, 3 is prime, 5 is prime, yes, 7, 11, 13, 17. Okay, cool. So I'm assuming this function works. Wait, it did say 2 is prime, right? It did. Wait, so we're good. Okay. So, blank line. So from this function, right? So from ENGR1 and 2, an import is prime. And we're done with that. So let's talk about the plan, right? Well, not done with the is prime. Let's talk about the plan. I've always said the same three things I've done to my reviews before. I say you need three things. You need the input, you need the process, and you know what the output is. The way I plan mine isn't particularly strictly top down or bottom up. Um, in my personal opinion, these prompts are not complex enough to truly do one or the other. Though I kind of assume the way I do it would be considered top down. But anyways, so first I'm going to find the input. The input, right? You can see that your input based on these example prompts. I'm going to have to do a input statement. Okay. But now note that bad input can happen, right? So that means I have to test for validity. Validity, right? And what I want here is to test an integer, right? So that means I will do a try except. So I'll do like try int input and accept. That will take care of bad inputs, right? And this itself will take care of good inputs. I probably want to condense this into a while loop. So I can keep asking over and over. As you can see that it asks multiple times, right? That's the input. The process, right, is I do one thing. I call a function, right? Um, sorry, I'm trying to think. Okay, so my process, right? Well, you see, I took a bit to think too, because I'm trying to see how we do this. Okay, so I will go through is prime, but I'm testing the odd numbers between and including those two numbers. Okay. Note that we never set in what order the numbers are to go in, right? I have inputs A and B. Let's say A and B, right? My start has to be the smaller of the two. My end has to be the larger of the two. Why do I want to do this? Because I want to do a for loop. I will do a for loop because I want to do every number between these, right? So for, num in range, start in +1, right? Because I said inclusive, including, right? I'm going to check if prime. And if so, I have a list right here. We refer the number to the list, right? Once you one step here, check if number is prime and odd. There you go. And that will check only the odd numbers. Cool. Okay. That's my process. Now, what about my output? My output just prints a list of numbers, the list of numbers found, or this, right? So this becomes my output, right? If length is greater than 0, then output the list. If length equals 0, output no primes found with the exclamation mark. All right. So first, are there any questions about this planning process? All right. In that case, let's continue on. We're gonna delete this. Actually, let me open a random file. Let me open the file. Okay. Close that. Let's see. Annotate, select. This goes bye-bye. And I'll leave this over here so we can look as a code. Right here. All right. So first thing I'm gonna do, so I like to do my comments first. It might seem weird, but I do my comments. One, it secures me with my free point for doing the comment, and two, it helps me structure my code a little better, or at least I have a better idea of my code. So first is test validity. I'm gonna get inputs for A and B, right? Then I guess for A, get input for A. Keep re-asking until A is valid positive integer. Right, it would be valid integer. Sorry. Okay. Now I get input for B. Keep re-asking until B is a valid integer. Okay, my process, right? Calculate start and end. Loop through start and end inclusive. Check for primes. If list exists, output it. If list is empty, prompt the user. What the user know. Already for my plan, I've made 8 comments. It's just from this plan alone. 8 comments. So I hear a lot, it's like, well, I don't really need comments. Well, when you make your comments first, you can see that you can definitely make at least one somewhere, right? That being said, let's start. So A equals input. And it says it should be enter an integer. Enter an integer with the space. Okay. Obviously, you don't want to cast this to int because that can cause the error. That's why I did try except. So we're going to try casting it to int. The other important part is to note that I asked for input outside the try. Actually, let me finish this and we'll continue talking. Except A equals input. Bad input. Try again. There you go. Okay. This is a very, very, very common way to wait. I can't. I'm sorry. Well, true. See, this is why these comments. I just read my thing, re-asking, so while loop, and I break. Okay, so I'll run this real quick, and we'll try it. Right? So integer, we'll do A. That's wrong. We'll do 1.0. It's still wrong. Negative 99 works. Great. So what am I doing here exactly, right? So first off, right, it's just ask for input. So you have 2 prompts, right? So this is your initial prompt. Should use this color. This is your initial prompt, right? It's just an input. Don't cast it in. That can cause an error, and that's why you have this int, right? So in here we do the thing that breaks. That can't break, right? Code, right? If this is successful, we're either here and we don't have to ask again, right? And that's great. Now, if this does break, right? like this breaks the program like into float or something, it goes here. And now see that you're just asking for input. You're not casting to it. Why? Because if you cast this to in as well, then you have to put a try except in here, and then another try except. I mean, you have infinitely nested try excepts, right? Outside of try is where everything, anything. Let me just erase this real quick. This, oh, this is where write possibly bad code. Bad as in like breaking, right? Particularly this line. This should always be valid. And then when outside also needs to be valid. If you think about it, it goes like this, right? We're gonna ask, verify, re-ask, and loop back like this. So we have one is my initial ask, right? I'm verifying with my try, and I'm re-asking on this. But then it cycles back and forth because I'm in a while loop. So we do verify, re-ask, verify, re-ask. If you did int here, right? Now you're doing 2 and 3 in the same thing, like this. Well, that is not, it's not very good because if that breaks, then you have very big issue in your hands. You might recognize this from one of your labs, where that one try except lab. This syntax looks oddly familiar, no? If you did this for your lab, you probably did it right. If you did it right, you probably did something like this. Right? No, we're not clear that. If any questions, feel free to ask. Otherwise, I'm just gonna keep strolling along. That being said, I can just do the same thing for B. We'll do this, but we'll do B. I will recheck the prompt. It says enter another integer. But the bat prompt is the same. Space that out. Space this out. If you're using Lockdown browser, I think you can still use copy paste, but double check your professor to be sure. And there you go. And that is for A and B. And that's the input. The input is now done. So let's do the process, right? So we have our list of primes, right? Our start is our min of A and B. Excuse me. Our end is our max of A and B. And now we're going to do a loop, which I actually did right out. For num in range start to end plus 1. If num mod 2 is, so this is odd, right? And is prime, num primes dot append num. And there you go. For loop if statement action. This you also see a lot, right? Now loop through something, do a condition, and then do something with it if it has the condition. You're gonna see this a lot. You've seen this a lot already. Be very careful about how and works as well, right? Note that it is it's a short. That means if this, it means that if the left side is false, the whole thing's false. It doesn't really care about the right side. So that's a neat trick. You know, it's always good if you're trying to verify something first, and you can use the and. Anyways, now we have that done. Excuse me. Now let's check the list. If length of list, not list, primes greater than 0, then we print primes and then the actual list. else reprint no primes. That should match what is here. So let's give it a little test run. And I probably overlooked something as usual. So it starts with 0.5. That's not good. 1 looks good. 1.5. 5. And there you go. Now I should probably remove this space here. Okay. I run it again. I put 8. I put 10. Okay, no primes found. That matches the other output. So any questions about question 37? It took me 20 minutes to sit here, talk with y'all through this entire code while also writing the actual useprint function. You can see that if you plan everything, I mean, it's easier said than done, but if you plan everything correctly and you know what tools to use, these prompts will take you mere minutes. But obviously, it's easy for me to say that because I have years of doing Python. So this is what, me doing this fast is expected. For someone who started learning for the first time, you probably don't recognize these, and doing inputs like this, or immediately figuring out the for loop. Or the if else should be somewhat simple, but using start and min and max to determine which number goes first, so your for loop doesn't go the wrong way, right? Be very, very, very careful, not just about the details we give you, but you have to be very careful about details we don't give you. If they don't tell you about something, you can't assume. That's something you can ask professor, like, oh, Professor Ritchie, or whoever professor is, or a PT, right? Can I assume that the first number is start and the second number is end? Something like that, right? But, if there's ever a time to be picky, this would be it. Like, definitely be extremely picky when it comes to these prompts, because we're supposed to provide you every single piece of information, but just enough information, right? All right, so that is question 37. Let's see question 38. Go a little faster now, but I'll still read and take my time. All right. So a file named data.dat is stored on a computer's hard drive. In the text editor, the file displays something below. The entire file is over 100 lines long. And these are contents. Some example contents right over here. Okay. So it says, write a Python program that reads the contents of this file, assigns the header lines to a variable that's in the list of strings, and assigns the data to a variable as a floating point NumPy array that contains all the data in the file. Then find and print the minimum temperature and maximum speed according to the file. Write this code using standard file IO. Do not use CSV module or any other CSV reader you may know of in some Python package. The professors want to emphasize using file input output, so we use CSV module. It kind of bypasses it because the whole point of a CSV module is to make reading CSV files very, very easy. I would look at the CSV module if you're interested in continuing Python, but I would avoid it at all costs if you don't plan on doing more coding, because it will just be more material that you may confuse yourself with that's banned on the exam anyways. Right, so in here I have the data file already made. I had the first few lines, right? And I'm gonna do a question, and do this question in quote unquote full speed. The way I'm more realistically do my programs is that I don't write out my planning. Very rarely, at least for these type of questions, do I write out planning. 102 didn't really plan too much, but would like to show, how comments can be very useful. So and I'm going to start writing anyways. I guess that's a lie on my end. Oops. Okay, so it's over 100 lines long. What does that mean? You don't even know what 100 lines are. You only know this format. Format. Okay, this right here. This is just info, right? This right here, headers, might be important. These are your units, right? And these is your data. This is your data, right? You have 1, 2, right? So 1, 2. So you split this on comma, you get 3 values that correspond with this, right? And now what do I want to do? I need to assign the header lines to a variable list of strings, right? So I guess this whole thing will be your header lines, right? I'm going to assign the data to a variable that is a floating point NumPy array. So I'm going to need NumPy. It's n by 3. So each of these is a row. Then find and print the minimum temperature and maximum wind speed recorded, right? And use standard IO. All right. So first thing I'm going to do is read the file. Okay. So we're just going to with open so data and read. Press input file. Now for what we're going to do, read the header lines. Okay. So our headers equals what? It will be input file. Well, I guess we can do it 2 ways, right? Read the lines. So lines we equal input file dot read lines. To separate the headers and data, make 2 different lists. Headers equals lines up to line index 3, and then data is everything 3 and afterwards. I print headers and print data. Oh, I hate this for this reason. Relative hash. I don't know why it does this, but oh right, it has to be let me put this right here. Cool. And you can see that I have all my lines. If you wanted to read each line by line, which is completely fine, right? We can do the following. So we do read the headers, and we do headers equals an empty list. And for I in range 3, right? Headers dot append input file dot read lines dot strip. And then for our data, we can do a similar thing. Okay, so data is a list. Now for I guess well data equals input file dot read lines. Okay, now print headers and data. We'll see 2 different things. I can't type. It's 1S. There we go. Okay, took on off. So we have our headers here, right? And then we have this stuff, right? I have our data separated, right? We can go ahead and just filter out. Sorry, it says specifically is to put all this in a NumPy array, right? Okay. So what we have to do, we have to filter out or clean data. So clean the data. Okay. So np data. We'll put whatever. Okay. So for I in range length of data, okay, we need to clean up each line. So new line equals data I dot strip. And now our line data is new line dot split on the comma. So we can print out line data. You can see we now have all our values together. And what else we need to do is we need all these to be flips, right? Because our NumPy array has to be floating point. So here, floating point NumPy array. So we have to convert strings to floats, right? So for j in range, we'll do 3, right? Line data j equals float line data j. If you're going through a list and you're changing the types of everything, just do this exact format. You're gonna loop through the list with indices, right? And you just assign the new value, right? So you do function, same value here, same value here. And that's it. That's how you can change a whole list to ints or strings or floats or whatever you want. This for loop is very, very powerful because, well, our files are strings. What are you going to do when you have floats or ends or booleans even, you know? Now note that I did not account for missing data, cough, cough, letter data. I would clarify with the professor if you can assume all the data is correct. Like there's no empty spaces, there's no weird shenanigans, right? For the sake of this problem, I'm going to assume that all the data is correct. So there will be no if statement to check for missing data. All right. Now, if I print out, oh, sorry. I should make a new list. Put cleaned data. Well, I guess I can do this. We'll do data I equals my data, right? And then we'll print data. And there you go. I now have a 2D list, right? And every list contains 3 floats. All I have to do is make the NumPy array. Make NumPy array. So np data is np.array data. I didn't import NumPy, did I? Nope. Just this. Okay, so import NumPy as np. Okay, so I print np data. I get this very nice 4x3 array, which is what we want, right? An n by 3 array. So 4 lines, 4 rows. So far, so good. Now, note that we just need the minimum temperature and a maximum wind speed, right? So I'm gonna look through. So temperature is this one, right? So look through this column, right? And then for the wind speed, wait for this. I can ignore the time. Okay, that means I want the first column and the second column, but like, if we're sorry, if we're doing zero indexing, right? We want the first column and the second column. So this is one. This is index. This is column 2, and this is column 1. So we'll do just that. So you get stats. So min temp equals np.min. Np, and remember what I said earlier, is you can specify the row and column in a single square bracket thing. So I want all the rows. So colon, right? And then just the first column. And then next, max wind, right? It's np.max, np data, and do colon, comma, 2. And there you go. And now the output. Print, see, minimum temperature is min temp. I put the F. Min temp, F, printf maximum wind speed is max wind knots. Okay, I'm not quite done yet. You see how these are 2 decimal points? You probably want 2 decimal points. Safest bet is to have your answer match the same formatting as it on the prompt. We give this a run. I misspelled max on these. Okay, you can see in this temperature, right? 13.59 is the smallest, 1.95 is the highest. So this is so far so good. All right. Let's say they wanted us to use this to get our units, right? In that case, we'll do extract units. So my units will be headers 2, right? Okay. So what I want to do is, well, we're going to strip and split on the comma. The neat thing, okay, I'm going to do some very fancy stuff real quick. We're going to do this, that. We're going to, we're going to do 1 comma negative 1. Okay, so I'm going to print units. I hope this works. Oh, I keep hearing it's 1, 2, 3. Bingo. Yeah. I keep reading as a comment. So this whole line, right? So first I strip it, right? So I'm strip and remove anything from the back. Then I do this string slicing. What does this string slicing do? 3 is right here. So all this stuff goes away. And then negative 1 means this goes away. Right? Now, if I split on this whole string, right? That means this whole thing goes away. This whole thing goes away. And that means I'm left with just my units. Minutes, degrees F, and knots. Yeah. So from there, we can wrap up, right? So our temp unit is units 1 dot split on the space 1, and then our win unit is units 2. Oh, that's it. So when I press in here, we do temp unit and we do win unit. Hopefully it's giving error. And there you go. And this prompt, I'm not sure how particularly picky Dr. Richie is of using the this, because I'm not gonna, this header is a little tricky to decipher. Knowing to, even I forgot for a second, knowing to strip and then removing all of this at the first and then splitting on its entire weird substring to isolate the units without the parentheses. That might be a little extreme. I don't know. Yeah, if you can hard code, that probably be the thing I would ask the professor if I was a student, right? Can I assume these are the same temperatures, or do I have to read the read the header file, read the headlines, and decipher them myself? All right. That is actually question 38. Any questions about this program? A better version will output the time as well. Yeah. Do. Output the time. Okay, I had to rewrite my code quite a bit. I had to do the time. But um, hmm, NumPy, but locate the time. I guess you would run through each row and then loop through, compare, and whatnot, and then store time. All right. So no more questions. So we'll move on to 39. Open up 39. Bring this here. Close that. Yeah, use a loop is what I would consider too. Unless you use a .iloc, but I'm not quite sure. I don't remember how it works too well. Okay, so question 39 says to write a function that takes in its parameters to NumPy arrays A and B and checks that the inner dimensions of A and B match. And if they do, calculates A times B. This is cross products, not product. If they don't match, have your function return an empty NumPy array. The inner dimensions of two matrices are two interior numbers, matrices with these dimensions. Okay. So first things first, import NumPy. Right. Now let's make a function. So def, let's call it matrix mults. All right. Right. So we'll take array 1 and A2. I guess we'll do mat1, mat2, a little more clear. And this calculates the matrix, sorry, the cross product, matrix cross product of the two matrices, if possible. Okay, so the question is, how do I check if they're compatible? So with matrices, right? Remember that dot shape exists. So inner mat1 equals mat1 dot shape, and then inner 2 right? So we're getting the shape. It's a property right now. A function is just a property. You need a shape. See that these dimensions have to match, right? And A goes before B. So this is my A, this is my B, right? So when I get the 2, 3 for my shape, right? This is index 1. And when I get my 3, 4 from my B, this is index 0. 0 and 1. Now we just do our check. Return empty array if not matching. So if inner 1 not equal to inner mat2, then we return np.array of nothing. Right? Else return mat1 at mat2. And there we go. So we have these functions. Oh, let's try these. Okay. So a equals np.array, add a comma here, 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 here. Then we have this one. So b equals np.array. Sorry, commas. This one here, here, here. Also, oh, not there. Here, 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 here. Good. So if I print, and I really hope this works, a b, gosh dang it, capital B. we get exactly this. The at symbol is matrix multiplication. You could have said this as well. Wait, no. It's np.matmul, isn't it? Yeah, very equivalent. Equivalent to I learned this way first, so I have it, but I think in the tutorial they use matmul to be more clear. This is probably more readable because matmul implies matrix multiplications. It's quite in the name, right? But either way works. I'll get you the right answer. Now let's do this one, right? So we took out some of these numbers. Here we go, empty list. So this one, if you knew the shape property, which I think you're supposed to know, and you know the matrix multiplication function, either the at sign like this or np.matmul, then this function becomes just a do you remember these two or not? Basically it. Oh, that and np.array. So nothing super crazy about this one. Any questions about this question? All right. So um, I'm gonna take a quick break because my throat is insanely dry. 5 minute break. We'll be back at 4:56. So break until 4:56 p.m. Okay, I lied. 4:57. 7 p.m. Right. Again, if you have questions, feel free to ask. I'll be getting water real quick. I'll be back. All right. Wait, I'm gonna mute. Right, I'm gonna mute. Okay. So, it's 47. So, let's wrap the show. Oh, I say wrap up. We have another hour in here. Okay. So, question 40. Oh, these problems. Pain. Okay. An Armstrong number is a positive integer where the sum of its integers, each raised to the power of the number of digits, is equal to the digit itself. For example, 371 is an Armstrong number as the following is true. Okay, so I need to write a function that takes two integers and returns a list of all the numbers between those two integers, and then write main code that takes input. Okay. This problem is basically the same as the is primes problem, except I have to write out the function. We're basically using functions. So we use main, we use this Armstrong number function, and we need another function to identify if it's a Armstrong number or not in the first place. I could copy paste my code, but for the sake of writing it out, I will still write out the full while loops and whatnot for input. But that being said, let's give this a whirl. So first off is this time I have to write my own function to verify if it's Armstrong or not. I have to write my own function to verify if it is an Armstrong number or not. So to define is Armstrong, and we'll take in some number, okay, and docstring returns true if the number, what is this, identifies, sorry, validates the number as an Armstrong. No, checks. That's when checks if number is an Armstrong number. English, my second language. Such a weird language, man. All right. So, anyways, less ranting, more typing. So you want to extract the digits, right? So digits. I should note that my number right now is a string. I'll just do that. Should that would be confusing. My number, just remember that my number at the moment is a string. Okay. So digits will be a list of number. And then for we'll just extract digits. Right. So for I in range length digits, digits I equals int digits, not dict I, there you go. All right, and then the math. Okay, so return, oh, actually, let's do this. Digits I equals int power length digits. Okay, return sum of the digits equals number. Let me verify this real quick. Would you print is Armstrong number? Should work for 4. Sorry, I said it should be a string. What? All right, we're going to need to do a little bug. This is really awkward on my end now. I'm definitely missing something. Okay, let's write a comment here. I should write a comment here. Number is a string. Do, 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 do. True, there we go. Right. My brain is now functional. 5, 6. And then 7 should not work. Oh, sorry, you can't see the problem. 7 works as well. So 8. So 9. But not 10. Excellent. 153. 370. And 371. Okay, cool. So my function itself works. I probably lost a point for not converting correctly. Even though if a PT is not checking that clearly, they might give full points, but don't depend on that. Do math. Do math. All right. I say that because I did that once myself and got really awkward. Anyways, so now we have to make the actual function, right? So returns list of Armstrong members. Oh, I just make a docstring for that. Define arm capital Armstrong number. So we'll do start and end. Returns list of all Armstrong capital A numbers, right? And now, at this point, right, start and end should be correct. So we'll just loop and check. So arm numbers equals empty list. For number in range, start in plus 1 because the end is included. Arm numbers dot append. Oh, sorry. If is Armstrong. This is why you should name your stuff accordingly. This reads very nicely as well. Arm numbers dot append number and return arm numbers. Okay, so let's say I will try. That's 100 to 400. Right. Okay, I really need to start playing more. There you go. Perfect. Okay. Well, almost, but yeah, the list is correct. Yeah, look, if I am in it wrong without comments, I highly recommend you use comments as well. Well, to be honest, I'm just kind of bad right now, but oh well. All right, so now we have a main function, right? So main, you don't really use a docstring for main. It's just main. I guess what's main function? Yay. Okay. So now we cover inputs, right? Grab first number. So we'll do a equals input, enter an integer, then we validate a. So while true, excuse me, a equals int a, break, wait, hold on. Try a equals int a, break, except, oh, main code is like the literally main code. Okay, gotcha. I thought main code meant to put it literally in main, but that works too. Okay, input, what is it? Bad. Okay, so two things. Okay, so if check if positive, if positive, like what? Okay, if a is less than or equal to 0, then a equals input need a positive integer. And we also cast that to int. Right, cool. Well, that input, try again. Right, so let's try out this thing because I might have effed it up entirely. All right, so if I run this real quick, okay, so -1, 2.5, 4 should work. Okay, yeah, so that works. Cool. What if I do, like let's do -1, we'll do A, and more A, like -1, right? And then 2. There you go. I clarify this. The only reason that I have this whole thing inside here is because this is like a special prompt, right? Before I break this loop, I have one more condition check that it's, you know, I now I think out loud, it's still wrong. All right, we will do the following. A equals input, and then we continue. Let's try this one more time. Okay, so -1, -1, -1, -1, -2, -3, 1. Cool. Okay, now let's talk about it. So if I have a prompt, right, and so we still have like this, this, and this, right? So we have our ask into verify into, well, this time you have two things, right? You have a negative prompt and just bad prompts, right? Goes back here, goes back here. Okay, so you're just asking parts number 1. The verify here is number 2. And this right here is 3. This right here is 4. Now, why are you split off like this? Because you can have a valid number, a valid like integer, but it also has to be positive. So with this if statement here, what I do is that if it is negative, right, I ask for another input, right? I don't verify it quite yet, but I just ask for another input. I could verify with int maybe, but I don't really like that because if this breaks and there's issues, right? When it jumps here, then there's a lot of bad stuff that happens to that. So, so all I do is just ask for input again, right? Just ask for input. Then continue. This continue forces me to go back up to the try. So this branch is free with 2. Otherwise, it would hit the break and stop the whole program or the whole while loop. That's all I want. This continue allows me to go from step 3 to back to step 2, verify. Now, obviously, if this fails, right, then you jump here, so 2 to 4, and this will then jump back up here because we're in a while loop. So do be very careful of when you have exceptions to what would be, a valid input. Knowing when to cast your input to a float or int or whatever type it's supposed to be. It's usually in a float or using a while loop where we try accept. Knowing when to cast is very critical because if you go a bit out of order, you're going to do some weird branching that will affect your code, right? So out of laziness, I will copy paste. And sorry, I mean lazy, because I'm an efficient programmer. We will copy paste this in B, and then this is another. And then we change this to B. B, 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 and B. Cool. Now this done, we just we calculate the start and end, right? So start equals sorry, start will be the minimum of A and B, end will be the max of A and B, and we will print out our result equals Armstrong number start end, and we'll do our output. Print Armstrong numbers result. All right, let's go ahead and give this a whirl. Right, -1, 0.5, 4, good, 2.7, -27, 27. Oh, wait, that's correct. Okay, cool. That gave me a heart attack for a second. All right, we run this again. 100, 400. There you go. That is question 40. So a bit longer than S prime because you have to write out the actual function to check. The function, well, wait, this you have to do anyways. And yeah, so just having to write this is a little longer, but not too long. Obviously the logic is more or less the same anyways. Checking if it's an Armstrong number or not, and then checking your inputs for validity. And then again, using min to max to find out which number goes first. Any questions about this code? All right, so moving on to 41. And 41 is the same prompt, but with a perfect number instead. This will take a while. Okay, so a perfect number is a positive integer that's greater than 1. Greater than 1 and sorry. A perfect number is a positive integer greater than 1 that's equal to the sum of its proper divisors. And that means all divisors except itself. It gives you some examples, and then write a Python function that takes one input as a positive integer and returns true if it's perfect number or not. And then write main code takes as input an integer greater than 1, and then you keep asking them for input until they give you a correct input, and then you let them know or not if they correctly, if they did a perfect number or not. So grab question 41. Right. So first, our perfect number. So did we tell us what function to call it? Nope. We call it as perfect number. Determines if number is perfect or not. We can say return 42. Mathematically, that's not correct, but more seriousness. So we need a list of divisors. Right. Okay. Sorry. Edge case is number equals 1. So why is this an edge case? I guess not really an edge case. You make the it's not really an edge case. For it. Okay. So divisors equals empty. I can't here. And then now we loop and find divisors. Okay. So for I in for divisor and range 1 comma number, and this will exclude itself because it doesn't include it. If number mod divisor equals 1, divisors dot append divisor. And now do the math. Return sum of divisors is equal to the number. Let's check this real quick and hopefully you did it right the first time for once. I did not. What did I want? Wait, okay, hey, 0, cool. 28 should work. Sure. That means I also make sure that you double check your work. Obviously, I'm not really checking my work the same way you would. I have an IDE, so that helps a lot. But when you're done with your code, would look over very carefully about your code. Strike 7, that should work, right? Good. So this function's done. Very straightforward function, nothing very fancy. You can see, right, like my for loops so far have been very, very basic. Nothing algorithmic in any sense. It's just brute force, go find the numbers that I want. Okay. So now I'll make my main function. It's not needed, but it says main code, so my brain just says main. So main function. All right. So get the input. So num equals input. Enter an integer. Like the we'll just invalidate the number. So while it's true, try num equals int num, and then check if is positive integer. If num plus equals 0, num equals input, need a positive integer, continue, break, accept, num equals input, bad input, try it, and then do the output. Is perf output equals is, if not is perfect, num output plus equals not, print f string num output a perfect number. All right, let's give this a go. Oh, whoops. If name equals main, main. Right, -5, 0.5, a 28. That's good. Wait. Oh, I don't need this here. Cool. All right, good numbers. You have 1, that's good, and then 6 is perfect. And there you are. That is the code for problem 41. Again, same exact format as Armstrong numbers and its prime. Input validation as usual, right? And then this here, right? You can also write like this: if it's perfect num, and print f num is a perfect number, else print f num is not a perfect number. It's shorter and probably more readable anyways. We'll do 6, and we'll do 1, and there you go. Any second last line? This one. So this prevents you from accidentally executing code we imported. Here, I'll give you a quick example. Not this. 43. Do print high. So in this one, I'll say print high, right? In this one, I'll do nothing but import. When you import, it actually will, in certain case, execute your code. So to prevent the main call from being executed, right? You give it this if statement, which basically says if I am directly running the code, the program I'm in, then call main. If not, then don't call main. It's basically it's a protection against executing code when you're importing. You just want to import. This was covered in one of your lectures. I don't remember which one. I want to say it's lecture 9. Not too sure though. But using main definitely was covered at some point. All right. So thank you, Dr. Ritchie, for the clarification. If I sound tired, it's because I am. I'm not bored, I promise you. I'm dealing with some personal issues, and in fact, I haven't eaten all day yet. Anyways, 2 more problems, and then you're free. Okay. A file named itemcost.dat is stored on a computer's hard drive. In a text editor, the file displays the first few lines of the file below. The rest of the file is not shown. Write a Python program that reads the contents of this file, determines the most expensive item, and prints the information about the item and its cost of screen using the form below. Write your code using standard file IO commands. Do not use a CSV module or a CSV reader available in some Python package. Do not use any built-in sorting functions. You may assume all costs are unique. That means you can't use lists. Because what most people will do, and what I would do, is you put. Well, actually, no. This line might trip people up. The last time I did practice problems with this line in it, I made a dictionary. I want to say that was the birthday problem. It's somewhere in there that I did dictionary for this one. But this time, this is, if we ever tell you to sort something without using dot sort, you use a for loop and you're going to compare. I'm going to show you that right now. Okay, so we need item. Where's did I delete it? Oh. All right, so it makes it. Oh, it's right here. So item cost that. Oh, cute is here. Item cost that. All right. So I have this example file right here. All right. And first off, we open the file. With open item cost that. And in read mode, because I don't want to write or append to it. I just want to read it. As input file. Okay. So I want to skip the header. We don't need a header, right? So I want to say input file dot read line, and this moves the internal cursor to the next line. And now we can read in the lines and compare. Okay, so I'm gonna set some default values for my values. So I want the maximum expense, most expensive, right? So highest cost is empty string. Highest name equals this. Okay. So for line and input file. What do not read lines? Why are you doing this one? Lines equals input file. Got read lines. For line in lines. So if default value, split the data, right? So name, comma, cost equals line dot strip, right? Always gotta strip the line dot split on a comma. Now cost equals float cost, and that does that. Now, if we have any default values to take care of, higher cost equals the empty string, right? Then highest cost equals cost, highest name equals name. Compare and check. If highest cost is less than cost, highest cost equals cost, highest name equals name. Oh. And now we just need to input the output. Prints f the most expensive item is highest name and cost of highest cost oh, point to f. And we go print this out real quick. Sorry, what? Oh, in here. Okay, so we look at my file. Item 4 is the most expensive item. And do we name item 4? If I put the right here, still works. All right. So okay. So you can see that well, actually I don't know what else to say about this. Pretty straightforward program, but this fluid right here. Sorry. This okay, this fluid right here, super important. Oh, and plus use lines, okay. So right, you can first do what? Default values. Sorry, this is for if you're trying to find the highest of something and you can't use the list, right? As you go through each value, right, you need to update your default values, right? Update values to reference. So you think about it, right? You don't know what the true highest cost actually is. Reference. What if they're all really small negative integers, right? I mean, that'd be really weird, but if you set the highest cost to 0, then it's gonna be wrong. So you set it something that it just can't be, like a string. And you check, oh, if this, if I need a value to compare it to, then set it to the first value. That's what I'm trying to do, right? I want to set this as my reference, right? I want to assume this is my highest, and then use this as a baseline to check this number, this number, this number. So that is what I'm doing with that default value section. And then compare and check, right? This part, very basic. If statement, compare, exchange if you need to, or assign a new value you need to. You will see this a lot. I almost can guarantee it. I would not be surprised if there was a question there somehow that is, please don't use a list, or something that you should be using a list on anyways, but we want to test you, so we will make you not use a list. You've been told to not use a list before, I'm pretty sure, so there's also that. This is a good thing to remember as well, right? If you don't need, I guess this brings back to the point of you don't really need a list if you don't care about using the data later. You can just use a for loop and go through and just slam through all the values and then store the ones you want. You can use a list if you want, but don't make lists. Don't use lists if it's going to confuse you anymore. Like I said, right? Just keep it simple, right? You can't use a list, use the next best thing, for loop. Well, in this case, right, if you use a list, it'd be so much faster. All right, any questions about 42? All right, no questions. Let's wrap up the last question, then. This question I also go in. I'll actually go in somewhat close detail this time. All right. All right. Let's talk about question 43. Last problem in this whole thing. Okay. Write a Python program that will take as input from the user grades in a recent engineering 102 quiz. Save it to a file named grades.txt and print the average quiz grade to this grade. Have your program prompt the user for number of students first and take as input that renames and record finding scores. You may assume the user provides valid input. Write your code using standard file input output commands. Use the format shown below for your output file, which includes the header line and line columns. Line columns is probably what kills people the most. I don't know why, but it just does. Maybe y'all just not used to alignment yet, so this is a great question for that. First off, input. I need. Did I say need? I need to. Sorry, I'm just trying to make emphasis. I need to find what my input is. So I want to take a number of students and input that many names and scores. Cool. So my input, right? So I have one input, which I can cast to int safely, as number of students. Then use a for loop to get a name, which is a string probably, and get a score. Get a score, which is a float. Right. Now I read the whole prompt, right? So I'm hesitant in doing anything else with this, right? You could be like, oh, you could store it in a dictionary, you could store it in a list. I haven't written any of that down because, well, I read enough to like know what I'm going to do, but I'm going slow, so we're not going to get there yet. Next is process, right? So I'm going to print the average quiz grade, right? So we want to add up these scores, right? And use that for average. This is our sum, right? And our length is this. And that will get us the average. So far, so good. Now, what we have to do, now we have to write to the file with a header line columns, right? So I'll have some, file.write this line. But the thing is, I can't even write this line yet. So I need to know how much spacing do I want? And let's use this as a reference, right? The longest name is Cameron, 7 letters, and it's about 1-2 spaces. I can assume in this case my column width is 9, which is also equal to longest name. Sorry. Length of longest name plus 2. Right? So when I use my f string to format like my left side, right? So it'll be name on this side. And then I want to left align, right? Left align. And then this side, right, is length, longest, name, plus 2. Then I can do score. The same process is I can replace this with the name, and I can replace this with the actual score. Right? The output's simple enough, so I'm not going to write out the whole process for output, but note like how I don't want to say fast, but how simplistic. Okay, it's simple. It's not overly complex of how to organize your columns, right? The neatest thing is to left align or right align, whatever, right? And then see how the column is based, because your column size is based on the longest string, right? Because it has to fit at minimum that longest string of add some spacing. This also always sounds like um, part B of small functions where you had to format the card to fit in the longest string plus the two spaces on either side and the character, right? This is similar. So this time you maintain that it's just long enough for that and the two spaces. That being said, let's go ahead and direct the code. So I'm going to do a blank.py. Put blank right here. Why going blank? Because I want to move this stuff somewhere. It's on it. So I'll move this over here. Cool. All right. Once you're typing. All right. So first is get the input. Actually, first I'm going to open the file. All right. So with open, and it's called grades.txt, right? Okay. So grades.txt, and it's in write mode because I want to write as output file. So remind myself that, oh, I'm not reading from this, it's my output file instead. All right. And now, I get my input. Get number of students first. Right. So num of students equals int input. And let's see what the prompt is. Okay, so it's enter the number of students. Right. And then it is get the name and scores. Okay. So this is very tricky. Okay. So next line was input, enter the next name and score. Okay. If we assume valid input, right? It's always coming. Oh, I should write it here, right? This would be input not split, because I want to split on a space to separate a name and a score. Therefore, right, name score equals next line dot split. We don't define split. It's just define a string and split. It splits on space for you. Okay, and then score equals float score. Okay, first thing I'm gonna do, right? I want to have the average, right? Oh wait, I need to put for underscore in range number students. So if you don't use the loop variable, people usually use underscore since it kind of hides itself. Right. So I'm gonna do store sum for average, right? The total score equals 0. Okay. What you're gonna do is add it, right? So total score plus equal score. Cool. So add to sum. And now we have to add to file. And this means I should go and add my header line. I have to start somewhere. Sorry, store data. Let me do that. Excuse me, please. Okay, I would do do names. Okay, add some names. And names, I know that you don't need to do these two comments, but it makes more sense in my head. A name's a pen name. All right. And now I'm gonna figure out the average. Okay. So the score average was total score divided by number of students. So print The average grade for this quiz is a 1.4. Oh, sorry. Is score average. F. There you go. Okay. Now we want to write to the file. So we want to figure out column size. So in names, I'm actually gonna do one thing. Okay. So column size equals length. Now be very specific. It's the length of name plus 4 plus 2 equals 6. Why is my column size currently 6? What if every name I had somehow was shorter than the actual name header? My spacing would be name and 2 spaces. I need to maintain an order. So the minimum column size is 6 characters wide. All right. Now let's go through every name. So 4 name and names. Oh, sorry. No, I can do it. Yeah, 4 name and names. Column size equals max column size and length of name. Plus 2. All right. And now we write to file. So, oh wait, names and scores. Add to this. Scores dot append score. All right. Now let's write to the file. So we're gonna do let's do write the header line. All right. So output file dot write. Name column size. We'll just quote and then write rest of lines. For I in range length of names, output file dot write have string again, and this time we do inner, so be names I, right? And then this column size, and then the scores at I. Oh, I don't need this here. It'll just be this. Beautiful. We need a slash n here, slash n here, and hopefully that's it. Okay, let's do this a run. Okay. 5. So Amari. Oh, I didn't do this correctly. Whoops. I need to do 0.1f. This is also 0.1f. All right, there we go. There we go. Okay, so we have 5 students. We have Amari, 85. Blake, say 6.5. Cameron, 89.0, 89. Dylan, 89.5. Emerson, 97. Okay, the average grade is correct. I'll bring up, yeah, so this is correct, all right? And I'm gonna clear my drawings. And a moment of truth is to open my file. And there you go. There's my formatted file. The columns are very neat. And there you go. Here, I'll do this. You can see the 2 outputs side by side. And there you go. Before I said the second time. This is problem 43. And I am done with this part of the review. Any questions on number 43? All right. So before I end, I'm gonna talk a bit about exam prep and just some resources we have for y'all. Okay. So as I've shown you earlier, um, we have um, these links here, right? We have these links. Um, type these links will be where resources will be for TAO. Um, I am an officer for TAO. Um, feel free to message me in Discord. This is me. Um, or just email me. I'll write my email in the video description and I'll put it in a chat in just a bit. If you have any questions or concerns, thank you. Big thank you again to Dr. Ritchie for helping me today. Also, we have a review coming up held by Andrew, who is helping lead these reviews hosted by TAO, and the co-president, Lily. They'll be going over containers, files, and practice problems. If you are too tired from this session, like I am, you're free to watch their recording whenever it's up on the schedule website. If you go to the schedule, it will look like this, right? So today, when I upload my video, my link will go right here. Um, this is where Lily and Andrew's link will be. They have their Zoom for their meeting just in a bit. I have another meeting tomorrow, same time. We'll be going through the other set of practice problems instead. And then after me, we have Lily and Sam um, at the same time as these four PTs. And then let's see. Next Monday, we have another review. Um, another review by Sam and Andrew. Oh, that's on Tuesday. Yeah. Then Tuesday, got two more reviews. The 27th is next Monday. So this is the Monday following Thanksgiving break. Alex and Erica will be hosting one there, and then we end off with Yannick and Dominic wrapping us up on 5 or 8:30. All right. If you want to join the server, right, links right here, tx.ag/tau server. I'll zoom in a bit because it's quite small. I can't see there. Yeah, once again, this video is being recorded, right? Yeah, it's being recorded. Once I end this meeting, I will um, I'll upload and then hopefully it'll be over tomorrow. And tomorrow I'll also do my best to add in the chapters so you can see if you're looking for a certain section here when I do a particular problem, I'll have it highlighted in the video for you so you don't have to scroll through everything. All right. Are there any last minute questions for me? And I am open to any sort of questions, exam or favorite drink. I don't know. You don't have any questions for me? Yeah, exam's cumulative. It's kind of impossible for it to not be cumulative because well, everything's the application of the other stuff, right? Like file input out. So I'm not trying to say it's a stupid question. I'm just trying to explain that. Even though it is a heavy emphasis on here, let me actually open the Canvas link. We can look at the topic material. Canvas, multi-section. Okay. So if you go to multi-section, let's do in view. Never mind, it takes too long. Okay. You go to modules. which is, you can see that right here we have exam. Oh, okay, rinse mode. Exam 2 information. You click that. And then the practice problems I just did are this first link right here. I'll click that and you'll see all the problems I just worked on. Right. And here are all the main topics. Okay. So exam 2 is a focus on everything so far. Past exam 1, right? So dictionaries, top down, function, scope, tuples, immutable versus mutable, try except debugging, file input output, string processing, importing stuff, NumPy, Matplotlib, Docstrings, and whatnot. So exam focus is everything past exam 1. But because all this requires you to know how to do everything for exam 1, it's essentially a cumulative exam. That being said, this is the main topic. So um, technically everything exam 1 covers should be review. I'll just put it that way. But right, like I said earlier, I think Matplotlib NumPy is not heavily tested. You just need to know the stuff within the tutorials, recognize them, know what they do. That's basically it, right? Tomorrow I'll be going over this set right here. It's a really long set of problems, so it's gonna take us a bit. Okay, it's gonna take me a bit to go through all 38 effort cubes, but we'll get through it if I don't dive insanity, right? And then one of PT's Archer, very nice guy. He made a 102 cheat sheet for y'all. Looks like this. Very, very, very handy. We'll take a look if you need a quick, review on what stuff does. All right. So, anyways, thank you again for coming. If you're just watching, thank you for watching. I hope this video, this stream, helped y'all with your exam review.